Hello everyone, I'm Kim and a PhD student in Korea Aerospace University. My present topic is about the attitude control simulated result using various speed control gyros. I will describe my research as part of this table of contents. Let me begin to describe the history of the CubeSat program, a detailed attitude control simulation. We have developed nanosatellite since 2021, and the CubeSat 1 is launched in July 26, and we are developing CubeSat 5 now. And the CubeSat 5 is CubeSat 5 project period is November of 2012 to July of 2015, and the development status is in electrical integration. And funding sponsor is Korea Aerospace Research Institute. CubeSat 5 is non-satellite and 3 CubeSat, and less than 4 kilogram CubeSat. And the CubeSat 5 primary payload is infrared camera and the Geiger mirror tube. And the CubeSat 5 include the components for technology verification. One is the micro variable speed control moment gyros and the fuzzy control based MPPT. CubeSat 5 system specification is shown in this table. CubeSat 5 mission orbit is sun-synchronous orbit, and CubeSat 5 mission lifetime is estimated to more than 1 year. And CubeSat 5 will stabilize using MPQ and control moment gyros. Why will we use the CNG for CubeSat? If we can use the control moment gyros into CubeSat, we can more and various mission using CubeSat. CubeSat 5 has additional specification, and this is less than about 900 dirham, and general pointing is linear, and the stability is less than 0.15 degree, and attitude accuracy less than 5.5 degree, and modality is less than 2.1 degree. This block diagram is showing the CubeSat 5 HCS system architecture and interface. We use 2 microcontrollers for near real-time determination and control. So we can control and determine attitude faster than the other CubeSat. And we use the ISQC to CubeSat for transmitting data to components and receiving status data from sensor data. We will use 3 sensors for determining attitude. We use the sun sensors and the magnetometer and inertial measurement unit. And many sun sensors to CubeSat 5 in order to determine acquire the sun vector regardless of the attitude this is a component for attitude control. We use 2 actuators for controlling CubeSat. One is the magnetic focus, the other is control moment gyros. Magnetic focus is controlled by pulse width modulation, and control moment gyros controlled by Q. CubeSat 5 operation modem attitude control function is shown below table, and the combination of sensor and actuator will be changed according to operation mode. Next slide shows the concept for using actuator according to operation phase. At initial phase, CubeSat 5 will detect using MDQ, and CubeSat 5 will fire and track the sound using some sensor. After that, and normal operation, CubeSat 5 continues to fire and track sound and point nadir. And when we want to communicate to ground station, CubeSat 5 will point ground station. And we at mission observation, especially Earth observation, CubeSat 5 will point the desired target according to planned schedule. After that, we will perform CMG verification module. After that, we will check the status of control gyros and other electronics, and we will determine the gimbal angles and reorientate the gimbals. After that, we use the two actuators for the mission, and pointing nadir and pointing ground station and pointing the desired target. CubeSat 5 dynamics for simulation using MATLAB and Simulink. We consider many models in this simulation. We propagate SGT4 model and GPS model, and we consider disturbance model and sound sensor and actuator model. And dynamics is referred to a textbook of Jenkins, and the talk input is determined based on Lyapunov static condition. And at initial phase, we talk input using a BDAP controller, and after that we use a steering wheel controlling gyros. Initial phase attitude control simulation, as I told you, we will use the BDAP logic for the determining of CubeSat 5, and we will acquire and track control without the estimation of some vectors. The reason is about reduction of the effort and the load of microcontroller. And in this phase, we will use only amplitude for control attitude. After that, at normal phase, before the verification of control moment gyro, we will use magnetic torque for maneuver before the verification of control moment gyros, and we use the estimator for acquiring of some vectors, and if we need the ground, CubeSat 5 will point ground station while the ground station contact using MTQ. After that, after the verification of control and gyros, we will use two actuators for controlling attitude of CubeSat 5. This graph is showing the result of the simulation using control gyros and magnetic torques. Before using the control gyros, we have to estimate gimbal angle, because gimbal bias will be due to launch vibration. So we want to be used absolute encoder, but due to size problem, we have to use the incremental encoder in order to determine control gyro gimbal bias. We will use the risk scale solution to equation motion, and it is used for determining control movement gyro with gimbal bias. It is very simple concept. This simulation result shows the estimation of control moment gyro with gimbal angle, and we will input this profile, triangle profile, in the flywheel, and we can obtain this data. This data is about the iteration data, and we summarize statistically, and we can gimbal angle is 31.718 degrees. Actually, gimbal angle is 32 degrees in this simulation. So average error is 0.282 degree. And after that, if we need it, CMG gimbal angle reorientations will be performed. We use two strategies for reorientation. One is the null motion. This will be used the null motion if all CMG can operate normally, and using no redundant control moment gyro reorientation if 3 CMG will be able to be used for attitudinal control after initial test. We will test CMG on one axis if 2 or 3 CMG will be failed. And next slide is about the singularity avoidance strategy. One, we use the two methods. The method is used for avoiding the singularity of cost of phi. One is null motion, as I told you, and second, the general singularity work control algorithm. This concept is very simple. If the terms should be not determined mathematically, singularity will occur. But cost of phi can avoid singularity of attitudinal control using the worst term delta E in this simulation. This simulation shows that the singularity avoidance result in cost of phi. And this is cost of phi that is just ADCS engineer model. We use the parts which are test about radiation tests, such as total ionized dose. We will perform electrical integration test and perform the operation test in electrical test both level and environment test, and such as thermal and vibration test. Thank you for your attention.
Thank you very much. I'm glad to see that CubeSat is also moving up to that very much higher technology level. Do we have any questions about this new technology for saving power and using the attitude? Okay, I guess everybody are very hungry, and we have a very wonderful opportunity to ask questions during the lunch break, so let's learn much more.